Thanks everybody for joining us today. My name is Mark Schaefer. I am a project manager with INEMI. We've got Grace O'Malley here today. She'll be presenting on the call for participation for the adhesive characterization for optical packaging project. Want to let you know that you're on mute. If you do have any questions during the session, I would ask you to please type them into the chat window and we'll try to ask them. If they're clarifying questions, I will interrupt you, Grace, so that we can get that clarified. If they're things that can wait till the end, I'll let you finish and we'll ask them at the end. If there is time and the line isn't too noisy, I will let folks unmute themselves so they can ask their questions. But I do want to let you know, because everybody does ask, the recording and the presentation will be made available to everybody that registered within probably a week or so, a little faster than that, however long it takes us to get it out. We'll send a note. But with that, I want to turn it over to Grace. Thank you very much.
Great. Thank you, Mark. And as Mark mentioned, I'm going to give the presentation today, and I'm doing this because I've been the primary investigator on this project that we started with MIT about a year ago. But Mark will also be working on the project as well. So going forward, you can contact either of us for further information with regards to the INEMI aspect of the work that we're doing. So welcome and thank you very much for taking some time out to learn more about this adhesive characterization for optical packaging project that INEMI is running in cooperation with MIT. And as you can see here on the kind of footnote on this particular slide, this work is being supported by an NSF grant to MIT and in support of MIT's FUTUR-IC Alliance program, which is looking at more efficient and effective manufacturing of electronics, and with a particular focus on photonics. So if we can move forward to the next slide, I'll just give the official acknowledgement here from the grant. And I will highlight, because we're not going to have a presentation today from the FUTUR-IC group, but we have had them on some of our earlier webinars. So if you look at the last link there, the project overview and survey launch that we did at the end of fourth quarter, there's a very good overview there from Professor Anu Agarwal, who's also on the call today and could answer specific questions about FUTUR-IC, and also a video, the FUTUR-IC video, and a link to the MIT website. So just, I know some of you have already attended those meetings, so we didn't want to repeat that, but there is plenty of information available on the overall program. And this project is just one part of the technology area of the program that MIT is running, funded by NSF. Great. So with that, I'll just highlight a little bit of where INEMI fits here in the background. As many of you know, we're an industry consortium, very much industry-led consortium, focused on enabling new technologies into electronics manufacturing and getting them safely, effectively, and robustly into high volume. So we've actually been around for nearly 30 years. We'll have some celebrations hopefully next year on that. And we work always by looking ahead. So we do road mapping and forecasting. What are the new and emerging technologies or coming down in terms of assembly and manufacturing, but also what are the driving applications that are demanding these new technology changes. So we work in the road mapping, and then we do a lot of work both having discussions within our working groups on key areas related to electronics manufacturing and all aspects, not just photonics, for example, and not just focused on the sustainability aspects of electronics manufacturing. But as you will see, if you go to our website, we have a very broad project portfolio and activity portfolio looking at things like all types of interconnect, board assembly, advanced packaging, etc. And this is highlighted a little bit in the next slide, where really we see INEMI now as no longer just focused on kind of traditional system integration or even board level integration or packaging integration, but looking at it from an overall system integration. And that includes the now having more projects and activities supporting the sustainability goals that we have as organizations and societies. And also looking at the digitalization of manufacturing and how we can drive efficiencies along both our supply chain and in the manufacturing processes themselves to enhance the resource usage that we have, and also to include the value chain and value chain resiliency as well. I hear my audio isn't so good, so I'm going to turn off my camera if that's okay, and hopefully that will help. All right, so just quickly, if you could press the next button, 2 buttons or 3 buttons there, Mark. This just highlights a little bit of where we typically our work in these area focuses. In system integration, we can work on things like advanced materials for components and processes to support high volume. So you will see we've done work in a lot of solder interconnects in the past, and now with an interest in low temperature solders as well, which is also of interest to the photonics community. Next one, if you would, Mark. Thanks. I mentioned smart manufacturing, looking really to how we digitize the information we need to ensure, sustainable designs and assembly, and ultimately end-of-life recovery of electronic systems going forward. And then sustainability specifically address some of those issues from the whole stakeholder perspective along the value chain, and helps all of us, as I said, reach those goals and objectives that we have in this area. Okay, with that, I'll move on to the next slide. And this kind of focuses a little bit more on the kind of projects that we run. Again, this is for people who may not be too familiar with us. We are very much, it's pre-competitive. We're not about developing new products or new technologies, but about enabling the technologies to get into high volume or to address a gap where maybe the technologies aren't quite there yet. So we have a wide variety of outputs that come from the projects so it may be, and the 3 on the right-hand side or the 3 to the right here are probably where this project falls. So we will be looking at developing test methods to support the use of optical adhesives in co-package optic. We would like to publish at the end of this project best practices to the industry on maybe the test methods that we want to use, not just for characterizing the materials, but also for the validating the potential reliability and performance of the materials as well. So these highlight some of the projects. A very short summary, as I said, we have a very broad range of experience across nearly 30 years of collaborative projects in this area, but also with a great depth of knowledge across the sort of 80 or 90 members that we have who are drawn from across the globe and across the global value chain. So we have material suppliers, equipment suppliers, system integrators, and that list is readily available on our website. You'll see many names, some of the large guys, but also some of the smalls and startups who are working on key technology, new technology development areas. So with that, I'll quickly just give one example I think that fits well with the type of project that we're going to do here. And this is the RDL Adhesion Strength Measurement Project. And some of you may be aware we actually had a webinar on this just in the last few weeks. And that's available on our YouTube site if you're interested in this. But again, this is, this is addressing a gap where as we move into finer pitch and higher densities, the existing test methods and capabilities don't really support where the industry wants to go. So this particular project was looking at evaluating new measurement techniques, validating them with some, shall we say, extreme design considerations, and ultimately looking to develop recommendations and technical data that can be fed into the standards development organizations. And likewise, the project on the right is looking at measurement techniques for moisture in the polymers as well. So these 2 particular projects kind of fall under our advanced packaging area. And so we have quite a breadth of experience in doing these types of projects. So if we move then, so why are we working in this area? And really, I think like probably all of us sitting on the call today, we all anticipate and it's been forecasted by all the marketeers that there's going to be great growth, but in the optical space, and that's really driven by a number of key markets more recently, and I suppose more in the news right now is certainly data centers and the move to AI, and the increase in data needs around the world are really requiring us to move to the optical interconnect space. So with that in mind, and I know this is repeated, regularly through the market, we're now, the industry is now looking to see how we can enhance, improve, and move into high volume as quickly as possible. Anu presented a very nice slide, I think, when we did December. So if we move to the last one as well, it's not all about AI and data centers. Co-package optics are going to be utilized in many application spaces, but again, it is the drive to increase bandwidth and more data needs around the world. And there's going to be an iterative approach, different approaches for either cost or performance reasons will be looked at. So flip chip, pluggable optical connectors, and the MIT group, and even within the FUTUR-IC program, is looking at a wide variety of those. Our particular project is going to focus on some of the, is going to look at the adhesive direct interconnect project. And if we look at the next slide again, and this is drawn from the IDX report that they did on co-package optics last year, you can see they're focusing the key trend, particularly driven in this case by high-end data centers, to move to higher density and smaller interconnect paths, which will require things like optical adhesive usage. Okay, so I'll quickly cover, I think I quickly identified why the market trends are there, but, that's the motivation really behind this project. There's a growing market and interest in the market and the supply chain to understand what are the needs and requirements they're going to have to support photonics packaging as we move forward. So we see optical adhesives as being a key critical component, and we need to understand how we can enable the adhesive manufacturers, the equipment manufacturers who will support adhesive placement, curing, and assembly to be ready for the growth in these areas. And one of the gaps that had been highlighted regularly is that there's an industry-wide need to develop a better understanding of these materials, both in characterizing them for optical applications and developing the test methods, and also where are the gaps in the standards that can support high volume manufacturing. So those are really the motivations for this particular project. And if we move to the next, we'll see the overall kind of scope and objectives that we set out at the start of this project. We started this project in conjunction with the MIT team last year, and for the first phase was really to understand if this was going to be the right approach, if there was an interest in this. So we conduct, the first kind of major task that we had was communicating with the industry at large, and then running an industry survey to help us develop a knowledge base of the existing materials suppliers and what was going on in this area in terms of the materials, how they're being used in optoelectronic systems in general, and in particular, what are the plans for co-package optic applications, to understand the type of standards that are being leveraged right now to support the industry, and what the identified needs from the respondents would be. And now we're moving into the phase that'll be open to the industry at large, which is to look at, developing test vehicles and exploring new test methods to support the development and use of adhesives for these types of interconnect systems going forward, particularly in optical packaging applications. So if we move, I'll just quickly give a summary. We also had a webinar on this survey. We did a readout on the results in February. Their survey ran between December and January, and the webinar link is available there. If we move to the next slide, Mark, thank you. It'll just give you some of the key takeaways. It really reinforced the growing market areas and the interests from the market space. It did confirm the use of adhesives in many optoelectronic systems. So, you know, optical connectors, for example, and being a large area, but also the interest in moving to photonics packaging areas as well. We got some information back on what are the characteristics presently considered important or being characterized when people are evaluating and qualifying materials, and then ultimately looking at the adhesive bond to anticipate the performance and reliability requirements that they're going to get. What we found was there is a kind of a mixture of supporting standards. Obviously, when we talk about adhesives, there's a lot of focus on the mechanical integrity and stability of the bond that's formed. So there are existing standards in those areas, but not specifically focused on co-package optics applications, and also not focused on the optical requirements that are required of these adhesives. So a focus, say, on the thermal stability of these over time, because you need to consider the subsequent processing of these assemblies. You know, for a co-package optics module going on to a board assembly, perhaps being exposed to one or two solder reflows. You know, what are the implications on the bonds of in those cases? And likewise, some of the application spaces are becoming quite aggressive. If we look at the use of in data centers, where, you know, the temperature at which they're operating is increasing all the time, and now they're looking at new ways of controlling that, which includes immersing everything in you know, immersion coolants and things like that. So a lot of new considerations that are going to demand understanding, development of appropriate and relevant test methods for them, and ultimately will lead hopefully to new standards to support the industry going forward. So if we, so I just highlighted some of the important considerations. I think obvious ones, the curing properties and the mechanical properties and the reliability. But then when we look at optical adhesives, we also wanted to consider things like the optical transmission, and stability over time, you know, the assembly and processability issues as well, that both in situ when you're creating the bond, but also for subsequent assembly as well. And one of the key areas is having this low shrinkage to maintain mechanical and thermal and optical stability. Okay, so just bringing you back again to the motivation, and from this phase of the project is very much focused on getting a better understanding of the materials. This third bullet point here of the test methods and what needs to be developed. So with that in mind, if we move forward to the next slide, you know, here are the objectives that we have for this phase of the project, right, and the expected outcomes. So we really want to develop relevant test vehicles for the material studies that can be relevant and used in the industry, and ultimately perhaps be used by the Standards Development Organization. INEMI isn't a standards development organization, neither is MIT, but at least the output of a lot of our projects does feed into standards development. It's one of the big impacts for our members, is being able to speed up the development of relevant and robust standards through having a large and relevant body of technical work to help either refresh standards for new applications or develop new relevant standards. So with that in mind, you know, a second, you know, the rest of the objectives address, you know, evaluating and characterizing representative materials. It's not going to be a project about picking the best material at all. It'll be more about developing a suite of test methods that can be used across the industry to help enable adhesive suppliers to for example, to develop their materials, to understand the requirements first of all, and develop their solutions for particular applications faster, for the assembly and assembly people to understand the requirements they're going to have to incorporate into the assembly systems, and then also to understand better the reliability expectations of these materials and what we may have to consider and to ensure that we get the performance needed. We're investing a lot of money, as has been highlighted in many industry presentations. The packaging element of photonics is relatively expensive. So we're investing a lot in terms of the components and devices that are being put into these modules, through the, say PICs and connectors and micro lens systems, etc. So we want to ensure high yield and long-term performance with these. So ultimately then we'd like to be able to, from this project, develop at least guidelines and best practices in a couple of areas: material characterization initially, and then the test methodologies to help develop the supply chain and the standards to support the industry at large. Part of the objectives as well, in conjunction with the goals of the FUTUR-IC Alliance, is to publish results, so that we can inform and help the industry move forward. So there will be some publication coming out from this project. Particularly on the guidelines and some of the, I suppose, the do's and don'ts when we talk about the materials development, assembly processes, etc. Okay, we use this kind of little check sheet in INEMI about what the project is and what it is not. So I'll highlight the is nots here just because that's usually where the questions arise. But it's not going to be biased towards specific suppliers or geographies or market segments. It's open to anyone to participate in. We'll obviously try to avoid repeating prior or existing work, and we're very interested in any existing work, obviously, that's being published, and so welcome into it. It's not to determine what's the best adhesive, right, or even to rank any adhesives that we work with. It's to really help develop the knowledge base on the required characteristics that the industry wants for these particular applications. Okay, and we don't develop standards, so it's definitely not to develop a specific standard or to qualify components or things like that. And in reality, it won't have the bandwidth to focus on the optimization of the adhesives. That will probably come from the adhesive suppliers themselves, but it's obviously one of the benefits for adhesive suppliers to participate perhaps in this, because they'll get exposed to the requirements and needs from maybe for different application spaces, and also from different stakeholders along the value chain. Okay. And then on the other side, as I mentioned, it's to develop a knowledge base. It's to get an understanding of the test methods in use and those that are needed. We would like to, at the end of it, have a demonstrator or test vehicles, examples of those to evaluate relevant test methods, and hopefully that could be shared with the industry. If there's a gap in that, it would be good to know that so that we can, push on that to develop it. And we want to validate the test methods that we will explore. Some are already, bubbling up through the survey and through the discussions we've had with industry, and others we're open to, I think, looking at some new techniques as well, maybe that are in the research environment. Okay, depending on the time, and hopefully we will have time actually, because we've extended this project a little bit, we'll be able to do some failure analysis and start to get an understanding of what the failure modes that need to be considered will be in these application spaces. And then the last two refer to one of the objectives will be to share and publish guidelines and recommendations that come from the project. Okay, if we can move on, great. So the schedule I mentioned, and this is particularly for this part. We hope to start this in the July timeframe. So about a 16 to 18 month window here to complete, and this is at a very high level because when we start our follow-up meetings here, everyone will get a chance to who's interested in participating and continuing, get a chance we'll go through some of the subtasks here and we'll get an opportunity maybe to change or adjust a little bit. But in general, this will be the schedule: developing the test vehicle designs, review of the test material testing standards and methods, and that includes those that exist or are already, but those that maybe are in evaluation at an academic level, research level, or maybe in-house, because we also found when we did the survey, quite a lot of organizations were developing their own testing capabilities, either based on customer input, the application needs that they were specifically serving. And so there's obviously a need and a gap for the development of some of these new testing techniques. We will assemble and test selected test vehicle designs. It would be nice to have a couple of them, perhaps looking at different aspects that we want to test. And then do a report out. So the commitment, I suppose, would be to be involved for the next 18 months. And that's in line with the support that we're getting from MIT and NSF as well. Thank you. All right, so if we can move to the next one. So in terms of joining this project, first of all, I think it'd be great if you're interested and need more information, reach out to us, and then you can indicate your interest. We will actually, Mark, if you can jump to the next one. I probably, yeah. I'm just showing where we are kind of in the timeline of what's a typical INEMI project development schedule. So on the left, we are open to everyone in the industry to participate in. And now we're moving into the phase on the right, which is the execution or project phase. And that you do need to be a member of this project team to be enabled to work forward. So we're just at that point where we're going to be making a decision or you're going to be making a decision if you want to be further involved here between now and the end of June. And during this time, we'll refine or finalize the project plan, lock down, I think, the resource commitments that are needed and also who's going to commit to going forward. And then we do have a draft project plan outlined, but again, we're going to leave that open for new members to come in and, have an opportunity to maybe, adjust some of the interests or bring what they're interested in to it so it can be included in the project. Okay, so that's not finalized yet, but we can share the draft with you. And if we can move back the slides then, Mark. This meeting is kind of an introduction, which is great. And thank you again for joining. We will do a second workshop, a more interactive workshop in early June, which will actually be at MIT. MIT is hosting the IPSR International Spring Meeting there on the 5th and 6th. And on the morning of the 6th, we'll have a short workshop. It'll be about 90 minutes, but we'll have some speakers and just it'll be focused on the objectives of this project. So I think if you will be attending, it's an opportunity maybe to get face to face with some of the people involved and ask questions. So it's not a requirement. Unfortunately, it won't be available virtually, but we'll share a summary online afterwards. And then we will be starting a series of meetings that will still be open to the industry for probably 2 or 3 meetings before we would close it to the project members who are signing up. If you want to join the distribution list, please contact myself or Mark. Mark's email is there, and we'll make sure you're on the distribution list for those extra meetings and any feedback that comes out of the survey. Oh, not the survey, sorry, the workshop. And then we do have a project page on our INEMI website. So you can go to that. We'll be updating that and adding documentation and the presentations to it. It's a relatively new page, so we need to add the webinars and those things to it. But I included the links in this already in the earlier slides. But if you have any issues in finding further information, please contact us. So likewise, we'll be reaching out to people individually to see if you're interested, and we're happy to arrange a call to discuss this further with you. Okay, Mark.
Sorry, I was trying to find the project page to put in the chat.
Oh yeah, no worries.
Okay,
Sorry,
so I'll get there. All right, here's.
Yeah, no problem. Right. Okay. I did mention, and these are just kind of a bit of the glossary. You know, when you do project with INEMI or indeed with MIT, we have to have a kind of an illegal agreement to be involved, and we also have some documentation which we will make available on the statement of work, which sets out the project scope, background, purpose, benefits, and everything. So before anyone signs up, they'll have seen that, get an understanding of what the project requirements are and commitments from their organization's perspective, and also the project statement as well, which is something that or participating organizations need to sign off on. Okay. So we can deal with that if you're INEMI members or MIT members. You know, you can join straight away, and for non-members, we can have a discussion with you about how you can get to work with the project team. Okay, I think maybe that's it, Mark. Oh yeah, final one. Where to find more information? In big letters there, the project page. Hopefully the link works, and that'll take you to it. We will be updating it. I don't think it notifies you if it's updated, but you can check back with it. Or as they say, reach out to us, right? And then there's just additional information and contact details. This webinar will be available. You see INEMI TV there on YouTube. So as Mark mentioned, this presentation has been recorded. We will put both the presentation and the recording up online, and you'll get an individual email telling you how to access it. Okay, so with
Great.
that, hopefully it's given you an idea. Yeah, any questions?
Yeah, so I would ask if there's any questions, please add them into the chat, or you can use the raised hand function and we'll try to unmute you, and as long as the line isn't too noisy. The only thing that came into the chat while you were on the line, Grace, was from Anu. She wanted to clarify that the FUTUR-IC NSF program is actually a cooperative agreement and not a grant. I guess somewhere on one of the slides we said it was a grant. So just to clarify, just to clarify.
Yeah, no problem. Actually, Anu, I don't know if you have any additional comments. I didn't know if Anu was attending, but I'd like to thank her for her leadership on this whole, and it's a much bigger program than just this project. And MIT are leading this, but Anu and Pradnia, who's leading some of the technology areas. So Anu, I don't know if you had any additional comments you might like to make.
I just unmuted myself. Is that all right, Mark?
Yeah, that's great. Yeah. That's great.
Okay, great. Thank you. We actually are a whole group of people who've joined. Pradnya is sharing her screen with all of us. I joined separately as well, so I can ask questions. But yes, thank you, Grace, for that introduction. I think in addition to FUTUR-IC, we'd like to highlight the fact that the IPSRI roadmap on June 6th, as you said, is where all of this will begin. And is there some information that we can share? I have a draft program, or if people can share their emails with us, we'll add them to the next mailer of the IPSRI roadmap meeting, mailings that go out now at this point weekly. So that was
great. If you want, if you want to share it now, it'll be on the recording, Anu, so everyone will have it, and we'll make the links on the presentation live. You can send it to me and I'll add it to the presentation so it can be live. But likewise, because because we're already working together and you're on the project team, we can send out the information for you, to everybody who registered. And actually, a lot more people registered. Thank you to everyone who attended today. But there's been quite a lot of interest in this project, so it's quite a large list. Yeah.
Thank
so
you,
do you want to
Grace.
share
I'll send
something
that to
now?
you. I will send it to you so you can add
Okay.
it to the chat.
Yeah,
Thank you.
that's fine then. Great. Thank you. Great. Any additional questions?
So Brad has added a comment. So this is a great project. One item for emphasis is substrates, characterization of the substrates that we work with in optics and optical packaging, aluminum substrate treatments, anodizing, hard cost lens material types, coating on the lens. So.
Yeah, definitely. Substrates are definitely one of the hot topics in the industry, and not just for optical packaging, right? So I think, I would assume, again, Mark and I and Anu don't get to, or Pratnia get to decide what this project will be about. It's going to be the team members who will decide. So if there's an interest in creating test vehicles with different substrates, technologies, I think that can definitely be considered. And we do that regularly. That RDL project I mentioned earlier, which is RDL on substrates, has looked at organic substrates, silicon substrates, and is now looking at glass substrates technologies. So, certainly from an INEMI perspective, that certainly could be something that would be considered. I mean, the focus to date has very much been on the adhesive interconnect and integrity of that bond and the assembly issues. But obviously, if we can incorporate different test vehicles for the different application needs, that would be great. So we welcome your input, Brad.
Okay. Anything else from anyone? Use the raised hand, or any comments from the MIT team. I know we heard from Anu, if there's any other comments.
Okay, and as I said, we will follow up with you all, and we're happy to set up one-on-one calls with anyone who'd like to have further discussions. We will try and get all of those done here in the next few weeks, so that we can, assuming we've got clarity and critical mass, we can move forward on time at the end of June, start of July. Okay.
And Grace, I sent you the PDF of a draft agenda for the IPSRI meeting on 6th June. If you would like to share it in the chat, that would be awesome.
All right, super.
Thank you.
Okay, hang on a sec. I had closed my email so I wouldn't get annoyed. Hang on, I do that. Let's see. If I let's see. Okay, I have to save it first. So. Yeah, bear with me. I had some connectivity issues. Let me just see if I can send it over to Mark. Hang on. Yeah, so I knew, just while we're talking about it, maybe you can let everyone know the first day will be focused on the roadmap, right? And roadmap updates, which is focused on all aspects of photonics, correct?
First day of the IPSRI meeting?
IPSR roadmap, yeah. And then the second day there will actually be 3 workshops, correct?
Yes.
Okay.
That is correct.
Yeah,
Grace,
and if you...
Go ahead.
Yeah, maybe you can share what the other workshops are about. Mark, I just sent it to you. Maybe you can add it to the chat. For some reason, my email is hung up here.
I'm waiting for it to show up.
Okay. I'll pedal faster.
While it's showing up, I wanted to just check. that different folks are doing different reliability tests for the co-packaged optics. Is there a plan to collect the current testing that is being done, and if that is adequate or not, and what other tests need to be done? So there'll be, just like somebody mentioned, substrates. The tests also have to be understood and evaluated for reliability, right? And what are the goals of that reliability? How long do we expect that bond to last?
Yeah, that's a very good point. And we touched a little bit on it when we did the survey, but again, it was quite it was the first survey, and so we were trying to collect a lot of information on a lot of different areas. But I think we would probably use another survey, obviously work with the team, because it'll be of interest from the team perspective, but then validate that with another industry service survey. Thanks, Mark, on the needs and reliability. The project, probably won't be able to address every single case, but I think we'll look for the key ones that are driving change, right? And I can speak. We have another project actually in INEMI, which we're running, looking at immersion, the growth of immersion cooling in data centers. So now, and we have it particularly focused on optical components, because suppliers are being asked to warranty their lenses going into any liquid any customer might like for as long as they like, right? Which, we need some science here, right, to evaluate the different chemistries, see the impact both on the optical performance and on the liquids themselves of throwing all these electronics in there that weren't designed to go in there. So the reliability goalposts have moved again, right, in that particular case. So we're looking at what's involved, the start of that whole discussion, and that's a big discussion right now in the whole data center community. So again, it kind of complements all of this work. So maybe Anu or Pradnya, maybe you can just highlight the agendas now up, right?
Yeah, sure. Thanks for that. Oops. I'm not sure why there's a
Let me see if continue. I'll see if I can fix the audio for you, Anu.
Oh, I think it's fine now. Is this good?
Yeah, that's better. Yep, that's great. Thank you.
Okay, great. Thank you. So as Grace mentioned, on June 5th, there are all these talks that are focused on energy constraints, on electronic photonic packaging. Then there's, if you scroll down, then I can see better, and maybe, yeah, I can. And then we have a session on grand challenges for high volume manufacturing. And this is quite interesting also for folks on this call, because there's going to be some discussion about PFAS. And it would be good to have these adhesives or polymer-based adhesives, which we're trying to develop, without PFAS. And we'll have a talk on PFAS. We'll also have a talk about other critical materials by Ajay Gupta, one of our Future-IC members. And the PFAS talk will be by Professor Aristide Gumyusenge. And then there'll be new materials and applications. We'll talk about germanium, particularly silicon and germanium. Silicon, of course, is an old material, but how it can be incorporated together with germanium. And then come all the workshops. And then the first one on Friday is the one that Grace just referred to, the ACOP. Then the second workshop will be on how to accelerate all of the prototypes that we're making in labs into commercial manufacturing. And finally, there's a technology panel on next generation light sources, LEDs, lasers, and so on. And the close of the program will be how to scale the semiconductor innovation infrastructure. This will be a panel run by Dr. Linda Molnar, who's from NatCast. And NatCast is currently the one that's running the CHIPS Act programs and so on. So she is interested in discussing what are the needs that companies have in order to be successful startups in this space, and also what are the resources that they can provide that are pre-competitive for all of the companies in this space. So that's what this IPSRI meeting is about. And if there's any questions, please feel free to reach out to Pradnya or I. I'll put my email address in the chat there, and so will Pradnya. Thanks, Mark and Grace.
No
worries.
problem.
Thank you.
We'll add them to the presentation as well. I think it looks very interesting. A few days. It's always if you get an opportunity to go. It's all things photonics, and it's great discussion and good industry participation. From this ACOP project perspective, it's not a requirement that you go, and we will kind of have a summary of the discussion points at the workshop. Okay, from that workshop that we'll share with everybody on this line. But obviously, it would be great if people can attend. So thanks for sharing that, Anu. Great. Okay, I don't think we've any other questions come in.
I have not seen any.
All right, so we'll thank everyone for joining us, and hopefully we'll get the chance to either meet or work with you again in the future. And again, any questions, I think you should have our contact details by now. Okay, thank you.